Dear students, welcome to the lecture series on the topic engineering graphics. So today we are going to discuss about projections of the oblique solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now the oblique solids are the ones which are inclined to both the horizontal plane and the vertical plane. Now let us go through the statement to work out the order of orientation of this regular pentagonal pyramid with respect to the horizontal plane as well as the vertical plane. So a right regular pentagonal pyramid, edge of the base 25 millimeter and height of the pyramid is given to us as 50 millimeter. It rests on one of its base edges in the horizontal plane with its axis parallel to the VP. So it means that the pentagonal pyramid is standing upright while its base is resting onto the horizontal plane. So to begin with, we will assume that the base of the pyramid, which is pentagonal in shape, it is resting onto the horizontal plane. So in the top view, below the XY line, we are going to obtain the true shape of this pentagonal pyramid. So we are going to first of all draw the top view of the pentagonal pyramid to begin with. Now there are two orientations which are possible in this particular case. That is, one is this orientation. Pentagon may be available in this orientation, or the second orientation is this one. You can put your pentagon onto the horizontal plane in this orientation. Now we need to evaluate which one of these two orientations is appropriate one. So for that we need to go through the statement completely. That is, we are required to draw the projections of the pyramid when its axis is inclined at an angle of 30 degree to the horizontal plane and the plan of the axis is inclined at an angle of 45 degree to the vertical plane. Now let us start with the case number one, that is this orientation. Now if the pentagonal pyramid is located on the horizontal plane in this orientation, now does it satisfy the requirements of the problem? So let us check that out. Now the pentagonal pyramid is resting on one of its base edges in the horizontal plane while its axis is inclined at an angle of 30 degree to the horizontal plane. So if I have my pentagonal pyramid located in this orientation, which is corresponding to this 3D model, now if I just tilt it this way, that is, the axis should be at an angle of 30 degree to the horizontal plane, then the pyramid will be resting on one of its base edges. So this is the appropriate situation for this particular pyramid. But even if the pyramid is resting in this condition, I cannot tilt this pyramid in this orientation, because if I tilt this pyramid in this orientation, then this pyramid will be resting on the ground on the corner of its base. So I have to tilt this pyramid in this orientation, not in this orientation. So even if you draw the orientation of the pentagonal base of the pyramid over here, then we need to tilt it over here into this position. But let us say we choose this particular orientation of the base of the pyramid. So if I choose this orientation as the base of the pyramid, then even if whether I tilt this pyramid in this orientation, then what will happen? It will be resting on the corner of its base. You can see over here, if I tilt this pyramid in this orientation such that its axis is inclined at an angle of 30 degree to the horizontal plane, then the pyramid will be resting on this corner or this corner. Similarly, if I tilt this pyramid in this orientation, then again it will be resting on the corner of its base in the horizontal plane. So we conclude from this discussion that this is the incorrect position of the pyramid base onto the horizontal plane. So this is the accurate or the appropriate orientation of the base of the pyramid which we have to draw. But another thing, even with respect to this orientation, I am required to tilt my pyramid base into this orientation, that is the axis of the pyramid should be inclined like this, so that it should be resting on one of the edge of the base into the horizontal plane. So this is how we need to proceed. So with this background, so let us start drawing the projections of this right regular pentagonal pyramid. So the right regular means this is the pyramid which is having its axis perpendicular to the base. So it is a right solid. Now draw the XY line. So as we have discussed that in the top view, onto the horizontal plane we will be getting the true shape of the pentagonal base. So we have to draw the pentagon over here. In order to draw the pentagon, the edge view is given to us as 25 millimeter. So we'll draw this 25 millimeter, extend it using construction line, draw external angles of 72 degree, again mark edge length equal to 25 millimeter, again extend this edge using construction line, again extend this edge using construction line, draw external angles of 72 degree. So this will lead to the construction of this particular pentagonal base onto the horizontal plane. And since this figure is drawn onto the horizontal plane, so this will be drawn below the XY reference line. So step number 1, we have to draw the top view of this pentagonal pyramid. So top view will give us, please see, a pentagonal base will be visible plus all the 5 slant edges of this pyramid, they will be visible to us as we are looking at this pyramid from the top view. Now in order to locate the axis, now let me tell you one thing, many students, they often commit a mistake that they will be extending this line, that is they will be extending this vertical line joining corner C and D, and they will conclude that this is the axis of the pyramid. No, for any pentagonal shape you need to work out axis in a way that from every corner of the pyramid you work out perpendicular bisector of the opposite edge. So from B, draw perpendicular bisector of ED. From C, you draw perpendicular bisector onto the AE. From D, you draw perpendicular bisector of AB. From E, you draw perpendicular bisector of BC, and from A, you draw perpendicular bisector of CD. So wherever these 5 perpendicular bisectors they are going to join, you see we have drawn with construction lines 5 perpendicular bisectors originating from every corner of the base and meeting the bisector of the opposite edge which is opposite to this corner. So wherever these 5 perpendicular bisectors they are going to meet, this is going to lead us to the formation of the axis point. So it will lead to axis point O, and O1 point will be there onto the base. So O point we are going to label here, O1 point we are going to label onto the base. So O and O1 are the 2 axis points, and having located the axis point, another thing we must remember, this axis point will lie, please see, little bit below this construction line which is joining the corners C and D. So if you join corners or the ends C and D with a construction line, this O and O1 will be lying little bit below that. So no way you can extend this line and say that it is your axis line. One thing. Second, having obtained this axis point, now you need to join O with A, O with B. You can see O with A, O with B, O with C, O with D, and O with E. So I have joined them dark. Why I have joined them dark? Because all these slant edges you can see from this model that all these slant edges they will be visible from the top view. So having drawn these slant edges, now I can remove, because in your drawing sheet you cannot remove these construction lines, no need to remove it, but just to keep my picture clean I have removed the construction lines which I had used to locate the axis point. So having located the axis point, now I am going to locate the axis in the front view as well, so that I can draw the front view. Now I am provided with the fact that the height of this pentagonal pyramid is equal to 50 millimeter. Now I am going to measure axis height equal to 50 millimeter. So these are the projections of the base. Please see, these are the projections of the base where I am going to get projections for A dash, B dash, projections for E dash, C dash will be coming here. Projector from D, that is D dash point, will be located over here. So 3 points I have located, and now I will be locating the axis length. Axis height is equal to 50 millimeter. So I am going to mark this 50 millimeter over here, and then having located this axis point 50 millimeter above the XY plane, now I can join OA dash, OB dash, similarly OC dash, OD dash, OE dash. Now please see here, the projection of OA will be dotted. Projection of OA will be dotted, but since projection of OB is dark, so this projection of OB, it will overlap the dotted projections of, or the hidden projections of, OA. You see over here, OB you can see, OA you cannot see. So O dash, A dash should be dotted, but OB since it is dark, O dash, B dash since it is dark, so O dash, B dash is going to overlap the hidden line, that is O dash, A dash. So that is why there is no dotted line. So dotted line will be superimposed by the dark line. Similarly, OC is the darker slant edge. You can see OC, but another one OE, it is a lighter, that is, it is a hidden slant edge. So this has to be dotted, this has to be dark. So the dark slant edge will again supersede or overlap O dash, E dash. So O dash, E dash should have been dotted, but it has been overlapped by O dash, C dash. So that is why again a dark projection is available over here. And finally this is automatically visible, OD, O dash, D dash. So this is point O, this is point D. So the front view projections will be O dash, D dash. So this completes our front view for the right regular pentagonal pyramid, which is having its axis parallel to the vertical plane. You can see the axis is parallel to the vertical plane, and it is resting on its base on the horizontal plane. Now we have to carry out the rotation. So as I told you earlier, since this pyramid is resting on one of its base edges in HP, as the axis makes an angle of 30 degree to the horizontal plane, so I have to tilt this in this orientation. That is, this will be the orientation, only then it will be resting on edge of its base. Now one thing is there, that now I need to transfer this figure. Just like projections of plane, figure number 1 used to be true shape, figure number 2 was your edge view. So here you don't have the edge view because solid is having length, breadth and height. So second figure will show you the front view of the solid, while third figure will be, once again, this will be rotation or this will be translation. So only difference between plane and solid is, in solid you have the 3D front view, that is, you will have the front view which will be showing you the height of the solid, whereas in case of plane you were only getting the edge view. So over here in the third view we have to rotate this figure at an appropriate angle. So this angle is given to us 30 degree inclination of the axis with respect to the horizontal plane. So I have to rotate this figure at an angle of 30 degrees in such a way that my axis will be lying, please see, my axis will be lying at an angle of 30 degree to the XY reference line, and my edge A dash, B dash will be lying onto the horizontal plane. This is a tedious thing to do. You see, if I draw this axis angle 30 degree, please check this out. If I draw this axis angle of 30 degree over here, now I have to manipulate or manage this triangular figure. This triangular figure I have to manage in such a way that the edge of the corner A dash, B dash, it should lie on the XY line. So in a way, what I have to do, if I just cut this segment over here, then I can manage it in such a way that this corner should be resting onto the ground. That is, I have to manage this distance over here. So in order to make it simple, what we are going to do always, whenever the axis angle is given, Now the problem lies that in certain cases this corner might lie, if I shift this figure, this corner might lie above the horizontal plane or the XY line, or it may go below this XY line. So in order to avoid that problem, what we are going to do in every case, that the axis angle is usually given as the first inclination in most of the cases. So whatever is the angle of the axis, because this is a right solid, if this angle is 90 degree, this is, let us say, 30 degree, which is given to us. So automatically the angle of the base becomes 90 minus the axis angle. So this angle of the base with respect to axis is 90. Angle of the axis inclination with XY, it is given to us as 30 degree. So what we are going to do now, we are going to transfer this figure not with respect to axis, but with respect to base basically. So once we transfer it with respect to base, so always this corner of the base, edge of the base will be resting on the horizontal plane. So we need not move the structure up and down. So what we are going to do, we'll measure this angle equal to 60 degree. So please see, I'll draw this angle because later on I am going to rub this off. But just to make the construction easier, so rather than making 30 degree angle first of all and then trying to adjust this figure such that the corner should be meeting the XY point, what I am going to do, I am going to transfer this figure with respect to base, and with this corner of the triangle will be resting over here, and entire figure is being transferred at an angle of 60 degree. Now please see, how do I transfer this figure? I'll mark this point as 1, A dash B dash point as 1, O dash point will be my point second, C dash E dash point will be my point third, D dash point will be my point 4. So onto this 60 degree inclination line, point 1 lies here, point 2, that is axis point, lies here, point 3, that is point corresponding to C and E, C dash and E dash will lie here. This is my fourth point corresponding to D dash. So I'll measure all these distances. Point 1 will be 0 distance, point 2 I'll measure this distance, mark point 2, measure this distance, mark point 3, measure this distance, mark point 4. So having marked these 4 points, so please see, corresponding to points 1, 3 and 4, vertical distances, they are 0. But corresponding to point 2, this is the axis line. How much is the vertical distance? I am going to, since I am going to measure rectilinear distances only, so I'll measure this rectilinear distance from point 2 equal to 50 millimeter, which is the height of the axis. So this you can do with the help of your compass or the divider also. So from here, from point 2, draw a distance of 50 millimeter, which is equal to this axis height. So then you join this O dash with A dash B dash, you join O dash with C dash E dash, and then you join O dash with D dash. So since this is the first figure, so all these values of dash will be supplemented by 1. They will have suffix 1. So this is O1 dash, this is O11 dash, this is A1 dash, B1 dash, C1 dash, E1 dash and D1 dash. So now we have been able to successfully transfer this figure at an angle of, you see, the axis of the base is 60, but the axis of the axis is shown to us as 30 because it was given to us that the axis is inclined. So we transferred it with respect to the base of 60 degree angle just for the purpose of convenience. But since this is not given to us in the statement, so what we have to do, I am going to rub this off. So I will be rubbing this off in a while. So this I will be retaining 30 degree and this 60 degree I will be rubbing off. Now you see how many points are there. So we have already discussed this thing in the previous lecture, that number of points in every construction will be n plus 2 in case of a pyramid. So n are the points of the base, that is it is a pentagonal pyramid, so you have 5 points corresponding to the base and 2 points will be there corresponding to the axis. 1 point of the axis, that is at the vertex or the apex, and the second point of the axis which will be there at the base. So 7 points we do have over here. So corresponding to all the 7 points, now we have to find out the corresponding plan figure. That was the step number 4. So this will always be the corresponding view. So once again I repeat, Step number 1, it will be the true shape or the top view. Step number 2 will be the front view of the solid. Step number 3 will be the rotation or the translation of step number 2 figure over there. Step number 4 will be once again corresponding figure. So from all these 7 points, I am going to drop vertical projectors, and from the previous figure of the plan, again there are 7 points. So corresponding to these 7 points, I will be drawing the horizontal locus line. So wherever the corresponding points they will be meeting, they will be providing us with the resultant figure which will be obtained for the plan when the axis of this pentagonal pyramid happen to be inclined to the horizontal plane with respect to 30 degree. So front view has already been obtained. So please see, I have trimmed this 60 degree. So this 60 degree has been taken off. Now after taking off this, now I am going to show that this construction is made with respect to 30 degree axis inclination with respect to the horizontal plane. So just for ease, we had drawn this at an angle of 60 degree. Now we are going to draw perpendicular vertical from all these front view projection points and the horizontal projectors we have drawn from the previous construction of the plan. Let us find out the corresponding point. So here you see, first point we have identified is O1. So this is vertical projector from O1. This is horizontal projector from point O over here. Second, let us work out second point, A1. So this is the vertical projector for A1 dash. This is horizontal projector for A. Similarly, B2. Right? So here you have vertical projector over here. This should be B1 rather. So this should be B1. Right? So this is vertical projector from B1 dash. This is horizontal projector from B point. Now O11, this is the second axis point of the base. Just see, I have drawn a vertical projector from O11 dash, and then this is horizontal projector from O1. Similarly, E1, just see, this is vertical projector from E1 dash, and this is horizontal projector from E point. Similarly, you have C1, right? Horizontal projector from C and vertical projector from C1 dash. And finally, you have point D1. That is vertical projector from D1 dash wherever it intersects with the horizontal projector coming from D. So all these 7 points you can check. A1, B1, this is B1, B2, B1, C1, D1 and E1. All these 5 points they have been located. 2 axis points they have been located. Now I should remember that A1, B1, C1, D1, E1 they will be joining. Then O1, A1 will be joining. O1, B1 will be joining. O1, C1 will be joining. O1, D1 will be joining. O1, E1 will be joining. So this is the rough figure which I have developed. That is just to indicate the nature of the sketch, because just by locating points you are not able to be clear that what type of figure will be obtained. Now please see, it is a solid. So certain faces will be visible, certain faces will not be visible. So please check this figure. If I orient this figure in this orientation, then what will happen? Just see, this edge will not be visible to me. This edge will not be visible to me. This edge will not be visible to me. Similarly, this one and this one, these 2 edges, they are also not visible. Why? If I tilt it this way, this surface and this surface, these 3 surfaces, they are going to overshadow the surfaces which are going to be at the back. But every time you do not have the solid models with you to develop proper understanding. So what we need to understand from the 2D orthographic view, please see, since we are looking from this side, so whichever points they are closer to the observer, they will be visible to you clear, loud and clear, they will be drawn dark. But whichever points they are farthest away from the observer and they are closer to the plane, again I repeat, whichever points they are farthest away from the observer, these are the 2 points, A1 dash, B1 dash. Just see, this is A1 dash, this is B1 dash. So the points which are farthest away from the observer and which are closest to the plane, lines joining all those points should be drawn dotted. So please see, by looking at this, A1 dash and B1 dash happen to be the points which are farthest away from the observer and they are closest to the plane XY. So any lines which will be joining, so just see A1 dash, B1 dash will be dotted, A1 B1 will be dotted, B1 C1 will be dotted, A1 E1 will be dotted, O1 A1 will be dotted, and O1 B1 will be dotted. So these are 1, 2, 3, 4, 5. These lines, they are dotted. You can see this is not visible because this will be overshadowed. This and this, they will be overshadowed by this edge and this edge over here. Similarly, this slant edge and this slant edge, they will be overshadowed by the rest of the figure once you tilt it this way. So let us draw this view. So 1, 2, 3. Any edges which will be joining A1 and B1, they have to be drawn hidden. So hidden edges will be drawn by dotted lines. So 3 edges we have already drawn dotted. Another 2, O1 A1 and O1 B1. So this we have to treat as B1, right? So this is B1 edge over here. Then these are the outer edges. So this is my final figure. OD, you can see this is OD. OD will be visible. You can see this is closest to the observer. So this edge will be visible, loud and clear. So whatever edges they are visible, they have been drawn with the HB line. Whatever edges they are not visible, they have been drawn with the help of dotted line, which are hidden. Again I repeat, we are looking from the top. Looking from the top, whichever points they are farthest from the observer and closest to the plane, they have to be drawn dotted. Now what we observe over here, axis every time I have shown with the help of a blue color, whereas all other points I have shown with the help of black color. Reason, because always usually the axis orientation with respect to HP and VP are given. So we should be able to clearly identify the axis. So please see, the axis length was 50 millimeter over here, true length. But while this surface is inclined, while this axis is inclined at an angle of 30 degree with respect to HP in the plan, O1, O11, this is the reduced axis length. So this axis length has been reduced and this is called apparent length of the axis in plan, or it is called plan length of the axis. This is called plan of the axis. So O1, O11 is called plan of the axis. Now let us read out the second part of this question. Plan of the axis is inclined at an angle of 45 degree to VP. Now just like in case of planes, figure 4 was corresponding, figure 5 will be rotation or translation, just similar to projections of planes. So this figure has to be rotated. This figure has to be transformed to this orientation. What is this orientation? 45 degree to the vertical plane. So from here I am going to draw a projector line which will be 45 degree to the vertical plane, and onto this line which are the points which should be lying? These one, O1, O11, that is this surface of this picture should be lying on this line. Why? Because the plan of the axis is what? This is my O1 and O11. So this is the plan of the axis which is inclined at an angle of 45 degree to the vertical plane. So I need to shift this figure at an angle of 45 such that O1, O11 and D1, they should lie on this line. And the rest of the points, again I'll tell you how do we locate them using rectilinear distances over there. So please see, I have drawn a projection line at an angle of 45 degree with respect to the horizontal plane. Having drawn this projection line, I'll mark this angle as beta. Why this angle is beta? Because beta is the angle of orientation of the apparent length of the line, and O1 and O11 is apparent length of this axis, which will happen to be how much? 50 millimeter. So how much is this distance? This will be 50 multiplied by cos of 30 degree. So if I do it mathematically, or I can even measure this out, so this will work out to be somewhere closer to 40 or 38 millimeter. So whatever I get, so I have to transfer all of this figure with O1, O11 and D1 onto this line. So once again, I am going to break this figure into different components. this is my point number 1. Please check this out. Point number 1. This is my point number 2. This is my point number 3. This is my point number 4. And this is my point number 5. Corresponding to point 1, point 3 and point 5. Vertical distances, they are 0. So 3 points I will be straight away locating over here. Once I measure distance between point number 1, point number 3 and point number 5 over here. So just see, I have drawn this figure. Point number 1, 0 distance. So D2 is located. Point number 3, O11. So I'll measure this distance again at a 0 distance onto this line. O21 is located. Similarly, point number 5, I'll measure the distance of D1 to O1. So once this is measured, so O2 will be located. Now I measure the distance of point number 2 from D1. I measure this distance of point number 2 from D1, and from here I have to measure the vertical distance which is upwards. This will give me the location of E1. I'll measure the same distance which is no need to measure. This is equal. So once I measure only one distance, this distance of point E1 from this locus line is equal to distance of point C1 from this locus line. So from point 2, I will mark these two distances over here. So once I mark these two distances, so C2 and D2, they are automatically located. Similarly, this was point 1, point 2, point 3 and point 4. Now I move on to point 4. So from point 1, you measure the distance of point 4 over here. And once again, the locus distance from this point to A1 is equal to locus distance from this point to B1. So you mark these two distances. So again, A2 and B2, they are located. And after marking all these points, now you need to join all these points in a similar fashion as they were joined over here. That is, from A2 and B2, all the points which are joined, they will be dotted one. That is, all the lines which will be joined, they will be hidden one only. So A2 and B2 are those edges. You can see this is the edge dotted because it is hidden. This is the edge, it is dotted, it is hidden. This is the edge which is dotted, it is hidden. This is the edge which is dotted, it is hidden. This is the edge which is the dotted, it is hidden. So these 5 edges from A to B2, they are hidden. Now which side? This way figure number 5 has been completed. So after completing figure 5, it is nothing but rotating or translating this figure with respect to vertical plane at an angle of 45 such that the axis has been located onto this particular projection line. That is all. Now having located all these points, we have joined them in the similar fashion as it was done in the previous case. Now figure number 6, just like in projection of planes, this will be again corresponding figure. So 7 points are available here, 7 points are available in this figure. So from the plan projection of the oblique lamina, we are going to draw vertical projectors upwards, and similarly from the elevation projection which was obtained in the previous iteration, horizontal projectors will be drawn towards right. So wherever the corresponding points will be worked out, they will provide us the shape of the final oblique lamina in the front view. But once again, which side we are looking from? Please see, we are looking from this side. So those points which are those edges of the surfaces which are closer to the object will be appearing to us as a solid line. That is, they will be visible to us. But whichever edge is farthest from the observer, please check this figure before we draw this one. We are looking from this side. So C2 is the farthest point from the observer. So C2 is the farthest point from the observer and closest to the XY reference line. So any lines which are going to join in this figure with respect to C2, they will be drawn dotted. Rest everything will be drawn dark over here. So after you locate 7 points, then we will find out where does C2 point lies. And wherever C2 lies, everything joining C2 should be drawn dotted over there. So let us do that. We have drawn the vertical projectors, as I told you, from all the 7 points of the plan which are obtained in step number 5. Now from step number 3, whatever 7 points were available from the elevation, horizontal projectors will be drawn. and the corresponding meeting points, they will be identified. So just see, this is the point for A1, A2, B2, C2, D2, E2. So let us join all of them. So please see, this is for A. So A point lies here. This is A2. So this is A1 dash. This gives us A2 dash. Similarly, this is B2. You take this up. B1 dash lies here. So again, B2 lies on the XY line. Let us talk about C. So C2 lies here. Take it up. From C1 dash, draw the horizontal projector. We get the location of C2 dash. Then you have D2. Where is D2? D2 lies here. So D2, you take the vertical projector up and then take horizontal projector from D1 dash. Then you have E point. So from E2, take the vertical projector up and draw the horizontal projector from E1 dash. Similarly, the axis point O1 dash, and then this is O2, and similarly this is another axis point which is lying O21, and this is O11 dash. So this will give us O21 dash. Now having drawn these 7 points, now we can join, because I very easily remember that A2 dash, B2 dash, C2 dash, D2 dash, E2 dash and A2 dash, they will be joining, so that my pentagonal figure will be completed. Just see, I have simply joined A2 dash, B2 dash, C2 dash, D2 dash, E2 dash and again A2 dash. And then another thing I need to join, all the slant edges. All the parts of the base will be joining. All the slant edges should be joining. First of all, I am joining them light. Then I'll see to it which points I want, which edges I want to draw hidden, which edges I want to draw dark. So I have to join, please check, O2 dash, A2 dash, O2 dash, B2 dash, O2 dash, C2 dash, O2 dash, D2 dash, O2 dash, E2 dash. So I have obtained the picture in front of me, but till now I haven't worked out which of these edges will be visible, which of these edges will not be visible. So please check. I am looking from this side, having obtained this nature of the figure using 2H pencil, that is light line construction lines. Now I want to draw the final figure of the elevation. So C2 point happens to be farthest away from the observer, as the observer is looking at this object in the plan view from this direction. So C2 is the point which is farthest away from the observer or closest to the XY line. So any of the edges which are joining C2 dash, they will be dotted. Rest everything will be dark. So let us complete it. C2 dash, B2 dash has been drawn dotted. C2 dash, D2 dash has been drawn dotted. And C2 dash, O2 dash has been drawn dotted. Rest everything should be dark. So this completes our view, and this was the point O21. For the axis, please check. Axis always I have drawn by blue color, and otherwise also the axis lines, they are joining by small, big, small, big, small, big. So these are the lines with medium thickness, small, big, or even in the projections also I was using small, big for the, you can see, construction of the axis lines over here. So everywhere I am joining axis with small, big, small, big. You can see this was the axis line. So this completes our problem of an oblique pentagonal pyramid whose axis happens to be inclined with respect to the horizontal plane at an angle of 30 degree, and the plan of the axis which has been obtained over here, this plan of the axis happens to be inclined to the vertical plane at an angle of 45 degree. And finally, I'll just once again repeat the difference between hidden lines and the non-hidden lines. If you are looking from this side, A1 dash, B1 dash were the points which were farthest away from the observer. So any lines which were joining A1 and B1, they are drawn hidden over here. Similarly, if you are looking at this object from this end, C2 was the point or the corner or the edge which was farthest away from the observer. So any of the lines, edges which are joining C2 dash, they have been drawn dotted. So once you understand this basic fundamental, so any problem on projections of the oblique solids, you will be able to attempt. So with this background, we wind up this lecture. So I hope with this elaborated discussion on the projections of the oblique solid, you will be able to work out any problems related to the projections of the oblique solid. So we are going to continue with the further discussion on more problems related to projections of the oblique solids in the next lecture. So thank you very much. Thanks a lot.